Okay. Going to be lazy and do the graph this way. Okay, so they give you a table, they give you time, they give you velocity, and they want the graph.
Will they provide graph?
Oh yeah, for sure. In fact, they expect you to use graph paper to get full marks. And sometimes they even say that in the question, you need to use graph paper. I just said you will get graph paper, don't worry. Yes. Okay, so this is a time velocity graph. Give you the velocity, give you the time. What goes on the x-axis? Time. And what goes on the y-axis? Velocity. And how many marks for the graph? 4 marks. So, let me just hear time. Okay. Would you... Okay. Velocity. Would you be so kind as to read out the times to me, please? What are they?
0.
Did they all go up in 4s, is it?
No.
Oh, they don't, okay.
0, 5.
5?
Yeah.
Oh, sorry. Did they go up in 5s?
0, 5, 10, 15, yeah. 5.
Up to 35?
Yeah.
Okay, and velocities?
0, 4, 8.
0, 4, 8,
12, 3 times.
12, 3 times.
And then
6,
0.
Okay. Right, graph time. Insert chart. Okay. Scatter this one. Well, I kind of want this one. Possibly. I'm not sure. For the assignment anyways. Okay. Right, title is, I'll give it just a year. It is 2013 B3 huh? But I said 13. And this is time velocity graph. I don't want the legend. On the x-axis is time in seconds. On the y-axis is velocity in meters per second. I want my x and y, and no, this is the 2013 paper. Yeah. All right. Finish. Come on. Right, there we go. Let me just shrink it a little bit. No, I don't want to do that. Come on. Doesn't matter, I won't shrink it. No! Yes. Shrink. There we go. Okay. There, that's nice. You give me that on graph paper, I'll give you 4 marks. Not bad, right? So that's part 1. Part 2, use the graph to calculate the acceleration. Now I won't write it down because I want to switch between the two. Okay, so you can write it down. So if I want the acceleration, I wish I had my meter stick because then I can point. If I want the acceleration, what's the formula for acceleration on the graph? Slope. Yeah. So what's the velocity? It goes up to 12, doesn't it? And the base, 15. So 12 over 15, what's that, please? Can you type it in? 0.8, is it?
0.80.
Yeah, can you write that down? And write down how you got the answer, okay?
Acceleration on the graph equal to the slope.
Yeah. What's wrong, Panish? You look confused.
No, I'm looking at the next one.
Oh, no, what is the next one? Read it to me.
Deceleration.
Deceleration. So that's at the end, isn't it? So what's the height at the end?
12.
And the base?
10.
So minus 1.2 meters per second squared.
When it says deceleration, it's supposed to be positive.
Oh, thank you for reminding me. Yes, deceleration is 1.2 meters per second squared. Because they said deceleration.
Is that okay? Just mention deceleration and not negative.
No, well, no. How many marks is it? Don't put me in that situation where I have to make that judgment call. Don't do that to me. I really should be positive 1.2 because they had deceleration.
Or if they just mentioned changing without mentioning deceleration.
If they mention what?
If they just mentioned changing, what's the acceleration from?
Oh, well, if they said what's the acceleration, then you must write minus 1.2. If they said deceleration, it's 1.2. So that's the answer. So I don't need to write that down. You're writing that down, yes? What's the next part?
Use the graph to determine the total distance traveled by the car.
Area. So write this down. Let's look up, guys, and you can write as well. So first is the triangle. So it's a half, say with me, a half by 15 by 12. Okay? Did you write that down? Plus, so a half by 10, sorry, half by 15 by 12. Yes? Are you okay down there? Did you write that down?
Half by 15 by 12.
Yes. No, if you need to write it on the screen, I can write it on the screen. It's just I like to have the graph up as I'm talking. But here, I'll write it. Oh, I don't have my marker. Did you write it down? Do you know what's going on? Don't. Here, no, let her help you. Let her help you. Oh, wait, did you write down the acceleration? No, okay, I'll write it down. No, it's okay. It's okay. Right. So I've done part 1. Now part 2. Acceleration is the slope. What was the height, please? Can you remind me? 12 over 15. That is. Okay.
We can square it.
Thank you. And what's next? Deceleration? I'll just write D for decel. No. A with a D here. It is. Well, what was the formula? 12 over 10, was it? And Donna, I'm getting those numbers here from the graph. It's the height over the base, and then the height over the base. Okay. Now what's next? Part 4 is the distance, which is the area, which is a half 15 by 12 plus 10 by 12 plus a half 10 by 12. All right. Problem?
270.
Oh, thank you. 270. Right. No. Meters. Come on. Right. What is the maximum momentum? So what's the formula for momentum? mv. So the mass is 980. And what is the maximum velocity? 12. So 11760 kilogram meters per second. How many marks have I done so far for that question?
11.
So far in this exam from section B, I've done 31 marks between the pendulum and the graph here. Alright? So part B now, if you look at B, it looks like something we've done in section A, doesn't it? What does it remind you of in section A? The moments, isn't it? So let's draw this diagram here. So let's see, how many weights do I have? I have a 4 kilogram. Let's see. The plank, the plank itself of wood is 4 kilograms. So right in the middle here, there's 4G. And then there. Yeah, but what's that block on the top? Hang on. That's 8. Right, and the 8 is here. And I'll just write in the distances. This distance is to the center, so it's 1.5. This distance here, they give it to you as 1.6. Okay. What else? That's it, is it? For weights. But then there are 2 legs. So there are 2 reaction forces. So there's a reaction force here, I'll call it R, and then there's a reaction force here, I'll call it S. Are you given those distances?
We're not giving the from
Oh, we are.
to 4G is not 1.5.
Huh?
There's nothing given to 1.5 to 4G.
The 4G? Yeah, it's the center of gravity.
Yeah, but you're 1.5.
Yeah, because the plank is.
Oh,
You alright? Doing okay? Here, this is 1 meter. Isn't it? Yes. And then how far to the next one? It is 2.5 meters, isn't it? So hang on, let me just make that a bit clearer. 1 meter, 2.5 meters. Are we all cool with that diagram there? So, what's the up forces here? R plus S. And what's the down forces? 12G. So I get R plus S should equal 117.72. First equation. How do I make the second equation? The turning force, isn't it? So, yeah, what's the clockwise ones? Sorry, the anti-clockwise ones. That's this one, isn't it?
From where?
From here.
From
This one and this one should equal that one and that one. Turning force. So we get now 1 or plus 2.5 S should equal 1.5 4G plus 1.6 8G. So I get R plus 2.5 S should equal uh, 184, is it? Yeah, 428. Right. What's nice about these equations is I should use elimination because the r's are ready to cancel. So here I would get 1.5s equals 66.708. So I get S equals 44.472 newtons. And then if I just plug that back in here, I can get the or. 73? Yeah. So I have just done part 1 and 2 for how many marks? 6. Last part is the object is gradually pushed towards end A. Determine the distance of the object from A when the plank just begins to lose contact with the support D. Now that is an interesting question, but it's only for 3 marks at the end. So don't worry if you didn't understand it fully. But what they're saying that's happening here is this block of 8G, let me actually, here. What's happening is this is being moved, different colors, this way. So in other words, it's no longer 1.6, let's just call it X. And they're saying here that this block, if we picture it here, is being pushed until what? It says until it loses contact with S, which is which one? Oh, sorry, you kindly gave it to me as S already, didn't you? The one on the right. So what do you think that means, that sentence? What does that sentence mean? Push the block until contact with S is lost. What does that mean? Yes?
The block is before R.
Possibly, but numbers. What does it mean for numbers?
1.695.
That's it. S is 0. They're saying push this until S is 0. Because if S was 0, it means now it's no longer in contact. Think about it. If I push here, I always have a reaction. Except when my hand is just about to leave. At that point, there's no more reaction. So contact is lost when the S is 0. So now what they're saying is basically this. Find X if S is 0. That's the question. Find X if S is 0. Oh, and by the way, the OR is no longer going to be the same. Okay. It'll be bigger, you're right, because it will have to, yeah, it's bearing more of the load. Okay, so will we try, we can use this equation, except something's changing it. And we can use this equation, except something's changing it. So now I have R equals 12G, because S is 0. And now for the second one, I have or plus 0, because that's gone, equals 1.5 times 4G plus X times 8G. So I just put that in there and I can get my X. So let's do that. I got X equals 0.75 meters. I hope I did that right. Can someone else confirm that?
You just said S is 0.
is 0, yes.
Could we go back to that?
I didn't put S in this, did I?
No.
I hope not. I didn't. I just have or on the left, no S. Sorry, Thomas, just to be clear, what I'm doing is I'm rewriting these two, but when I rewrite it, whoops, I'm not putting the S in, I'm not putting the S in, and I've changed that to X. So that's how I get those two. Is that right?
Yeah.
Yep.